Hello everyone, my name is Pranjil Wadhwani. Today we will study about golden rectangle and golden ratio. It was said that a mathematician Hippasus discovered that the golden ratio was neither a whole number nor an irrational number. This ratio was named the golden ratio by the Greeks. In the world of mathematics, the numeric value is called phi, named for the Greek sculptor Phidias. Golden ratio is used in various fields such as mathematics, art, geometry, beauty, and many more. So first of all, to understand what is golden ratio, we need to understand what is golden rectangle. A rectangle is said to be a golden rectangle if it can be divided into two parts such that one part is square and other part is a rectangle similar to the original rectangle. Here you can see a rectangle ABCD which is divided into a square APQD and a rectangle QPBC similar to the original rectangle, that is ABCD. Now let AB equals to L, BC equals to B. Therefore, QP will be equals to B, which implies PB will be equals to L minus B. Now, according to the definition of golden rectangle, ABCD will be equivalent to QPBC. So we have AB upon QB equals to BC upon PB. Substituting the values, we get L by B equals to B upon L minus B. Now solving this equation, we get L square minus LB minus B square equals to 0. Now dividing this equation by B and then taking L by B equals to X, we get X square minus X plus 1 equals to 0. Now using quadratic formula, we get the value of X as root 5 plus 1 by 2. Thus, X equals to L by B, which will be equals to root 5 plus 1 by 2. That is, for a rectangle to become a golden rectangle, the ratio of its length and breadth must be equal to root 5 plus 1 by 2. And this ratio is called the golden ratio. Its value is about 1.6180339,887. Thus, it can be seen that the golden ratio is the ratio of the sides of a golden rectangle. Golden ratio is also known by other names such as extreme and mean ratio, medial section, divine proportion, golden cut, mean of Phidias, and many more. Now, when you turn the sequence of numbers into squares and lay them side by side to create a rectangle, a spiral starts to form, which is called a golden spiral. You can see in the figure on the screen. The example of golden spiral are shells and hurricanes and many more. Now let's see the relation of golden ratio and a continued fraction. Let us consider an example 1 plus 1 upon 1 plus 1 upon 1 plus an infinite continued fraction. Now considering the denominator section, that is 1 plus 1 upon 1 plus so on is x, then we get x equals to 1 plus 1 upon x. So we get x square minus x plus 1 equals to 0. And again the value of x equals to root 5 plus 1 by 2, which is a golden ratio. Now golden ratio, continued fraction and a sequence. Now as seen in the previous example, if we consider 1, we get the value as 1. Considering 1 plus 1 by 1, we get the value 2 by 1. Considering 1 plus 1 upon 1 plus 1 upon 1, we get 3 by 2, and keeping on doing so on, we get a series as 1, 2 by 1, 3 by 2, 5 by 3, 8 by 5 and so on. And this is a famous sequence called the Fibonacci sequence. It was found that the nth term of the Fibonacci sequence can be expressed in the form of golden ratio, that is root 5 plus 1 by 2. It is amazing to know that we can also see golden ratio in arts and architecture. As seen in the figure, the painting of Leonardo da Vinci. He said that golden ratio is a divine proportion. For example, in his famous painting of Mona Lisa, trying to draw a rectangle around face, we can see that the measurements are in golden proportion. Next, the Parthenon. It is a temple built in mid 5th century and dedicated to Greek goddess Athena Parthenon. The exterior dimension of Parthenon forms a perfect golden rectangle. The Egyptian pyramid. The basement of Egyptian pyramids divided by height of them gives a golden ratio. It is amazing that we, the humans, and the nature gifted by God is also in golden ratio. For example, in arms, the knuckles, fingers, hands, and different length of parts in your arm also fits golden ratio. Now this ratio 5 was also seen in Super 30 movie describing the beauty of the face. This ratio is also seen in seeds, shape of inner and outer surfaces of shells fits golden ratio, and also seen in snowflakes. At last, we can conclude that golden rectangle and golden ratio are very closely related concepts involving other mathematical concepts such as fractions, quadratic equations, trigonometry, sequences, and etc. We also saw the application in designing buildings, architecture, and structural engineering. So this was presentation by me on golden rectangle and golden ratio. Thank you for watching.